The area of a circle with radius r is pi r squared, and pi is the circumference over the diameter, which is approximately 3.14. However, what if I told you that this area of a circle is just a special case of a general formula? Well, I'm going to show you. If we have a regular polygon, alright, and we take its center, and by center I mean a point where the distance from this point to all of the vertices are equal, so that's the center. And if we take the center and we take the regular polygon's radius, right, r, then we can actually figure out the length of the base of the triangle that we form by drawing these two radiuses of the polygon. Now, I know that for this specific polygon it's 8-sided, but like the point is that I'm trying to make a general formula, okay? So here, if we were to calculate the length of this side, what would it be? Well, we're going to have to use something called cosine law. In order to use cosine law, we need an angle. We need the angle in between these two sides. And this one over here, this angle over here is just the entire 360 degrees, or 2 pi, and then over the number of sides, which is n. So 2 pi over n. So then using cosine law, we can write this as x. X squared is therefore equal to r squared plus r squared minus 2r squared times cosine 2 pi over n. So then now, if you were to simplify this, you get x squared is equal to 2 pi r squared minus 2 pi r squared times cosine 2 pi over n. That's nice. Now, what you can do is you can factor out 2r squared. So x squared is equal to 2r squared, and then you factor that out. It's just 1 minus cosine 2 pi over n. There we go. Now, if you were to take the square root, then x would be equal to the square root of 2r squared times 1 minus cosine 2 pi over n, and then there you go. Now, you can split this square root up like this, right? So then now the square root of 2r squared is just equal to r times root 2, and then you still have the square root of 1 minus cosine 2 pi over n. So then, how can we simplify this part? To simplify this, we're going to use the double angle formula for cosine, which is equal to cosine squared theta minus sine squared theta, right? This is the general formula. Now notice that cosine squared theta using the Pythagorean identity is just 1 minus sine squared theta. And now, after writing all of this, you can simplify this to 1 minus 2 sine squared theta. So then, cosine 2 theta is just really equal to 1 minus 2 sine squared theta. Now, notice what happens when you rearrange for 2 sine squared theta. If we were to subtract 1 on both sides, then we have cosine 2 theta minus 1 is equal to negative 2 sine squared theta. Now, if you multiply both sides by 1, then what you actually get is 1 minus cosine 2 theta is equal to 2 sine squared theta. Notice that in our case, for what we have over here, notice that this theta over here is actually, or rather, this 2 theta over here actually is 2 pi over n. So 2 theta represents 2 pi over n. And therefore, we would know that theta itself is equal to pi over n. So then substituting theta with pi over n, we just get 1 minus cosine 2 pi over n is equal to 2 sine squared pi over n. And there we have it. We can replace this, what's inside this square root, with 2 sine squared pi over n. And now, finally, if you were to simplify this square root, you would just get this is equal to r times the square root of 2 times, and now you can split this up as square root of 2, and then square root of sine squared pi over n. Now here we have a square and square root, so then this square and square root just cancels out. And square root of 2 times square root of 2 is just 2, so then we just get 2 times 2r times sine pi over n. And there we go. We basically simplified x, right? So what purpose does that serve? Well, what we're actually going to do is we're going to take the pi of the regular polygon. Now that might sound a little bit weird. However, notice that in a regular circle, pi is equal to the circumference over the diameter, right? In a similar case, we're going to define a pi n for an n-sided regular polygon. And this pi n is equal to that polygon's circumference or perimeter over its diameter, which would be 2r. So by the way, if you forgot, this is just equal to x. We simplified it all the way down to here. And now what we're going to do is we're going to solve for pi n. We're going to get this regular polygon's pi. Okay, so we have pi n. This is equal to the perimeter. The perimeter is just n times x. So that would be n times 2 times r times sine pi over n. And then now divided by 2r. Notice that this and this cancels, so then we're just left with pi n is equal to n times sine pi over n. So this is the general form of a regular polygon's pi, i.e. the perimeter over the diameter, right? Now, here's the interesting part. If you take n to go towards infinity, this actually approaches the exact value of pi. So you can write this as the limit of n sine pi over n as n goes towards infinity. This is just equal to the exact value of pi. And now you can evaluate this if you want to. We can rewrite what's inside this bracket as sine pi over n times pi. If you evaluate this, this is just n sine pi over n. So then now pi is a constant, so then you can just take this out. And now, look at this. This is the exact same case as evaluating sine x over x as x goes to infinity. Now this limit would just be 1, right? So then, you just get pi times 1. The entire limit is just 1, which is just pi. And there you go. So notice that this is really interesting. You can use the pi of a regular polygon to get the limit of it and approach the exact same pi that we find in circles. So this is the general form of the pi of any regular polygon, right? So how can we use this to calculate the perimeter and area of any regular polygon? Well, the perimeter would just be 2 pi n times the radius. And this is because this is what pi is literally defined as. We define pi n as the perimeter over the diameter. So if you were to just substitute this into here, you would just get the perimeter. So that's kind of because of the definition. However, and by the way, before I go on, notice that this is very similar to the circumference of a circle. So, however, how can we get the formula for the area of any regular polygon? I know a formula already exists, but how can we write this in a form similar to the area of a circle? Notice that earlier we had split this regular polygon into a triangle, right? Now if we were to split this up into all the triangles, all the identical triangles that we could split it up into, we just have to add up the areas of all of these triangles and we get the area. What we have to do is take the area of one of these triangles and then multiply it by n, since there are n of these triangles. So we can actually use the triangle formula with sine. So if we have a triangle with side length AB and then angle theta in between, then the area of this triangle is just equal to 1/2 times A times B times sine of theta. So then, if we apply this formula for one of these triangles, we just get that the area would be equal to 1/2 times r squared times sine of 2 pi over n. So now, we can actually get the area of one of these triangles, but then we want the entire area, so to do that, we have to multiply it by n to get the area of the entire polygon. Okay, so now let's simplify this. Notice we have sine of 2 pi over n. Notice that we can use the double angle formula for sine. So this would just be equal to 2 sine pi over n times cosine pi over n. Okay, so now let's replace this with this. So let's go ahead and do that. So here we have times 2 sine pi over n times cosine pi over n times n. Okay, we have 2 and 1/2. This just cancels out to 1. And there you have it. And now I'm going to rearrange this. So I'm going to write this as a is equal to r squared times n sine pi over n times cosine pi over n. Now, notice anything interesting here? Pi n is equal to n sine pi over n. Notice that we have n sine pi over n right over here. That's interesting. So then we can just replace this entire thing with the polygons pi or pi n. So then now, if we were to rearrange this, if we were just to write this professionally, we get that the area of this regular-sided polygon is just equal to pi subscript n times r squared times cosine pi over n. And that is the formula for the area of the regular polygon. Now, notice, once I erase all of this, now here's the interesting part. We can use this formula to explain the area of a circle's formula. Look at the area of a circle, pi r squared. The only difference here is that we don't have cosine pi over n. But why is that? Well, this is the formula for the area of any regular polygon. So if we take n to go towards infinity, we get an exact circle. Now what is this when n becomes infinity? Well, we have pi n, that's just the exact pi for the circle, right? And then we have still times r squared. But then for the cosine part, this becomes cosine pi over infinity. That just becomes cosine 0. So cosine 0 is just 1. And the area just turns out to be pi r squared. Notice that this area of a circle is just a special case of this general formula. What do you think? That's pretty nice, right? And also, we can also substitute n with any positive integer. For example, 1000. That would be getting the area of a 1000-sided regular polygon. So you can first calculate pi 1000 by using this formula over here. And then you can also substitute n with 1000, and then you get the area. That's pretty nice. So basically, you can use this formula for any general regular polygon. However, once again, the most fascinating part about this formula is that you can actually explain the area of a circle with this general formula, which I thought was just very, very nice. Okay, so I want to leave you with one more question. So if we have n equals to 50, no problem. We just get pi 50, and then we can just substitute n with 50, and then we get the area. No problem. However, what if n is equal to 5.5? Okay, well that's nice. We can get pi 5.5, just use this formula, and then we also substitute n with 5.5. It's pretty nice. But what does that mean? You're going to get a value, that's for sure, right? But like, what is A? A is the area. You're getting the area of a 5.5-sided regular polygon? What does that mean? Well, I actually don't know. We might just have to restrict n to be positive integers. Perhaps, maybe. But perhaps this also has a meaning. So, I don't know about that yet. Anyways, I hope you found this video very fascinating and helpful. Thank you.